Okay, so this is lesson 3, terminating and repeating decimals. It starts on page 12. Your keywords are denominator, integers, numerator, rational number, repeating decimals, and terminating decimal. So a rational number, there's rational and irrational numbers. A rational number can be written in the form of A over B, where A and B are integers, which means a whole number. Sometimes a negative whole number. B is not equal to 0, so integers and fractions are examples of rational numbers. So are decimals. If a rational number is written in the form of A over B, you can convert it into a decimal. Divide the numerator and the denominator using long division. The result will be either a repeating or a terminating decimal. Repeating decimal has one or more digits that repeat without an end. To represent a repeating decimal, draw a bar over the digits that repeat. A terminating decimal is a finite number of non-zero digits. Finite means it stops. If you continue dividing a terminating decimal, the digit 0 will repeat over and over again. All right, so how can 3 over 20 or 3/20 be expressed as a decimal? Does the decimal terminate or repeat? Divide the numerator by the denominator. So you see we've got 3 divided by 20, right? So numerator divided by the denominator. Well, 20 cannot go into 3. So I place a decimal point there and a 0. Because 3 is the same thing as 3 0/10, or 3 is the same thing as 3.0. So now I can divide it. So I put a 0 up here with a decimal point to show that my answer is going to be a decimal. So 20 can go into 30 one time, subtract and get 10. So now I have to put another 0 here because I don't want a remainder in my decimal, and I put 100. Now, 20 can go into 100 5 times, right? Which is 100. Subtract and get 0. And if I put another 0 down there, it's 0. 20 can go to 0 100 times. So does this stop? Do I have anything left down here? No, I don't. So it does terminate. Now, this is written over here as like 0, 0, and it repeats as zeros. But when it's a 0, when your number continues to be 0, that means it's terminated. There's nothing left. Only the digit 0 represents over and over again, so the decimal terminates. The rational number 3/20 can be expressed as a terminating decimal of 0.15 or 15/10. So like another way of saying that is 3/20 is equivalent to or 1500ths. Pi is, and I know you've heard about pi before, is equal to the decimal 3.141592655, and then it keeps going. And I know some people memorize like the first 20 or 40 digits of pi. A lot of times pi is written as 3.14, as just like a rounded version of pi. And if you don't know anything about pi, pi is actually the relationship between the circumference and the diameter of a circle. So for example, if a rounded version of the diameter equals 1, the circumference is going to be about 3. So the diameter here is about 1/3 of the circumference. So that's how pi works. Any circle that you measure, if it's a perfect circle, this is like a good kind of fun thing to do at home. Get a measuring tape or a piece of string that then you can use a ruler on and measure the circumference of any circular object. So like, for example, if I measured this can, right, and I measured the circumference of this, and I measured the diameter, and I divided the circumference by the diameter, I would get something very similar to pi. All right. Let's see how this works. Oh, and we did not finish that. So this is pi. Can that decimal be classified as rational? Why or why not? It is not rational because a rational number has to repeat or it has to terminate, right? And this does not terminate, it keeps going, and it does not repeat. These digits are kind of just random. There's no pattern to those. Like if you had a number 3.1414141414 and it just kept going, you would write this number as 3.14 with a line over the 1 and the 4 because it repeats. And this would be considered rational, okay? Because there's some sort of pattern to it. Or if you just had the number 3.14 and it stopped at 14, that would also be considered rational because it terminates or stops. An irrational number means that it does not have a pattern to it. It does not repeat or it does not terminate. It just keeps going in this kind of random pattern. That's considered irrational. So no, because it does not repeat and it does not terminate. Pi is irrational. All right, how can 5, 6 be represented as a decimal? Does the decimal terminate or repeat? So we're dividing the numerator by the denominator. Okay, so we're gonna do it right here. 5 can go into, or 6 can go into, can't go into 5, 0 times, you place the decimal and a couple zeros afterward. 6 can go into 50. 6 times 9 is 54, so 6 times 8 is 48. Subtract and get 2, bring down the 0. 6 can go into 20 3 times, which is 18. Subtract and get 2, bring down the 2. 6 can go into 20 3 times. Uh-oh, what's going to happen? 18, we're going to get another 2, 0. So it's going to then repeat, right? So is the result terminating or repeating? If you continue dividing, the digit 3 repeats over and over again. So the result is a repeating decimal. Write the decimal, the decimal is 0.83, and you can put a line over that 3 because it repeats. The rational number 5, 6 can be expressed in the repeating decimal as 0.83, and it is, with the repeat, and it is rational because it does repeat. How can 2/5 be expressed as a decimal? Does the decimal terminate or repeat? So we divide the numerator by the denominator. I'm going to do it a little bit bigger. So 5 cannot go into 2, so you place a decimal point. So 5 can go into 20 4 times. Pretty simple. So is the result terminating or repeating? If you continue dividing the digit, wait, isn't that true? 5 can go into 24 times. If you continue dividing the digit, so like if I put, so 4 can go into 5, 20 times, subtract, and get 0, place another 0, it's 0. 5 can go into 0, 0 times, which is 0, 0, subtract, and get 0, place another 0, 0. And it would continue on as zeros, right? It stops. So if you continue dividing the digit 0 repeats over and over again, so the result is a terminating decimal, right? The decimal is 0.4. The rational number 2/5 can be expressed as the decimal 0.4. That is a rational decimal because it terminates. Alrighty, what is a rational number? Rational numbers can be whole numbers. They can also be decimals that repeat or terminate. What is the difference between a repeating decimal and a terminating decimal? Obviously, a terminating decimal stops, or the or 0 just keeps repeating. And a repeating decimal does not stop, but has a pattern. Most repeating decimals have the same number that repeats. So for example, we had that 0.83 and the 3 repeated, but sometimes you will get like 0.1414141414, so the 14 is repeating. Sometimes, oops, sorry, you can't see that. Sometimes you'll even get 3 digits that repeat. That's a really cool one. All right, so what you're gonna do is convert each rational number to a terminating decimal and show your division work in the space below. So each one of these is going to be terminating, so you'll get that 0, 0, 0, which you don't need to do. Once you have nothing left over, you don't have to keep placing zeros in your dividend. Convert each rational number to a repeating decimal, show your division work in the space below. So these are going to repeat. So what I always recommend students do is at least get it so it repeats 3 times. It's repeated 3 times, so you know it's the same one. Most likely after the second one, you're gonna realize it, but it's always safe to do the 3rd time. So for example, let's do this one. So 3 divided by 2, right? No, sorry. 2 divided by 3, right? Yeah, 2 divided by 3. So I place my decimal point there and my 0 there. So 3 can go into 20, 6 times, which is 18, subtract and get 2, place another 0, 0 can go into it 6 times, which is 18. So you pretty much already have an idea of what's gonna happen here. Now I like to do it 3 times just to make sure, so you know your repeating decimal is gonna look like that. All right, and then you've got this beautiful word problem down here, and it's gonna ask you, is a decimal terminating or repeating? And then what you're gonna do on your own, which you may have to do on another piece of paper just to do the work. You could also, I know you know how to divide your numerator by your denominator using decimal work, so you could also use a calculator. So for example, 1 divided by 6 equals 0.1666666. And usually on a calculator, it's not gonna show you the dot, 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 but you know that if it goes all the way to the end, that's repeating. So your answer is 0.16 with a line over the 6, not over the 1/6, because the 1 does not repeat, just the 6. So the line goes just above the 6, and this is obviously a repeating decimal. And so this next one I'm gonna go ahead and do too. 9 divided by 50 equals 0.18. There's nothing after that, so you know that's a terminating, or it stops. All right, and then you're gonna continue doing this. If you've got any questions or concerns, or you don't know what to do, go ahead and email me or Google Chat, and I'll help you out, and we'll go over these answers when we Zoom next week.